This is the first problem that's worked out on the front side of worksheet 2A. You can see over here on the left side there is a 12 Newton force that's given, but it's at an angle. It points a little bit to the north and a little bit to the east. And so what you're going to have to do is split this into an Fy component and an Fx component. And I drew in blue right next to that just the pulled out version of that triangle. The 12 Newton force is the original hypotenuse that's given, and the two components that make up that 12 Newton force are the Fx and the Fy components. You see that I've got Fx parallel to the x-axis, and I've got Fy in the same direction as the y-axis. So then to solve this, we're going to use SOHCAHTOA, sine, cosine, and tangent, those same three trig ratios that you learned probably years ago. Sine is defined as the opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. It's all in relation to that 60-degree angle. So to solve for f sub x, I'm going to use the cosine ratio. The cosine of 60 degrees is the adjacent side, which is f sub x, divided by the 12 Newton hypotenuse, as you can see here on the right side. To solve that, I just multiply both sides by 12 newtons, and if your calculator is in degree mode, make sure you check that. You're going to multiply 12 times cosine of 60. You'll get fx has a value of 6 newtons. You're going to do the same thing to solve for f sub y. We're going to use the sine ratio because it relates to this 60-degree angle. Sine is the opposite side, which is Fy, divided by the 12 Newton hypotenuse. So I set that up in my trig ratio here. Multiply both sides by 12 newtons. You get 12 times sine of 60, and that should give you an Fy component value of 10 newtons. It is a long decimal in the calculator, but I rounded using significant figure rules. So try the other three, only work on the front side, and we'll see how it goes. We can talk about it when I come back tomorrow. Thanks.